Lapland jays running lip, 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 axe on their brow, lip, lip, lip. This means the northern lights. The lights are like the Lapland jay with an axe on its brow. That seems such a threatening poem. Were you very afraid of the northern lights when you were small? Yes, I was afraid, and sometimes I wasn't. Of course, we sometimes tried scoffing at them to see what the effect would be. Older people always said we shouldn't scoff at them, and they forbade us to do so. It's mortally dangerous if they grow angry. They can even kill you. They're said to have killed people sometimes. This axe is what they use. That, of course, is a superstition. Naturally, there are beliefs like this wherever the northern lights are seen. The rarer they are, the more fantastic the beliefs are. I've read somewhere that further south, where the northern lights often appear red, they're believed to be the torches of the gods, and are signs to the people of their sinful behavior, or that the gods are making merry in heaven, as was believed in, for example, Australia. Then further north, where the northern lights are seen more often, this superstition is not so frightening, and there are pleasant aspects. According to an Eskimo tale, the gods, moving about in heaven with torches, lead the dead to the land of plenty. Others believe jestingly that the spirits are playing with the skulls of walruses or whales. And by whistling, you can bring the northern lights nearer. The Greek philosopher Aristotle put forward his theory about the origin of the northern lights as long ago as 330 BC. According to his theory, vapors rose from the element earth through the heat of the sun. These vapors collided with the element fire, and the vapor went up in flames. The Roman Seneca, in about 60 AD, also spoke of a strong light he'd seen in the sky that was thought to be the blaze from a burning village in Ostia. What he saw were, however, the northern lights, the aurora borealis, a rarity in such southern latitudes. The international name for the light seen in the southern hemisphere is aurora australis, the southern lights. The Finnish name, Revontulet, includes the word repo, a name for the fox. Tradition has it that if you stroked the fur of this kind of fox, flames would flare up. Generally, the fox in the tale is a black one. This one is a cross between a black and a brown fox. As this fox roamed the fells of Lapland, his mighty tail brushed the snow and the bushes. And then there were great outbursts of light that set the sky ablaze. The old people say that the northern lights originated when the moonlight was reflected off the waves of the Arctic Ocean onto the clouds, and the lights move when there are great waves on the Arctic Ocean.
Jäämeressä.
In the early days of research into the Northern Lights, it was assumed that the reason for the Northern Lights was that the sun's rays from below the horizon struck extremely high clouds. The Northern Lights were also thought to be incomplete thunderstorms, material not developed into lightning, or vapors containing salt and brimstone. In the 18th century, a number of inventions and observations were made that had a revolutionary influence on research into the Northern Lights. Even in those days, it was noticed that the Northern Lights are connected with the Earth's magnetic field. Whenever any brief rapid changes take place in the magnetic field, that is, magnetic storms, the Northern Lights are almost sure to appear. It was also noted that the magnetic field lines and the vertical lines seen in the Northern Lights run in the same direction. The conjecture that the Northern Lights appear in both hemispheres simultaneously and in approximately the same form was also found to be correct. The assumption that the Northern Lights are electricity in the air was supported by the Finnish physicist Professor Selim Lemström, a man of influence at the end of the last century. He developed a theory on the cause of the Northern Lights. The experiments conducted to prove his theory are world famous even today, since they contain a hypothesis that still applies in part. In his book, published in Paris in 1886, Lemström gave a detailed account of his experiments. The book also contains numerous drawings on the Northern Lights theme. The Earth's atmosphere quickly thins out as one travels upwards. It consists at various heights of the same gases as those found near the Earth's surface. The main ones are nitrogen and oxygen. Beyond about 60 kilometers up, these gases are, however, in a state different from that near the Earth's surface. This thinner part of the atmosphere, rising to a height of hundreds of kilometers and capable of conducting electricity, is called the ionosphere. It's at these heights that the Northern Lights are observed. They appear most at a radius of about 23 degrees from the Earth's magnetic pole. To be more precise, they form an ellipse surrounding the poles, which is called the Northern Lights oval. The oval remains stationary in relation to the magnetic poles as the Earth rotates beneath it. As a result, the Northern Lights shift southwards late in the evening and return nearer the pole towards morning. The primary source of the Northern Lights is the sun. Charged particles, chiefly protons and electrons, are continually emitted from the sun into space, and some of them, as they approach the Earth, are directed at the Northern Lights zones under the influence of the magnetic field. As the particles collide with the atoms in the atmosphere, the Northern Lights appear. Thus, weak light, often invisible to the human eye, is always in the sky at high latitudes. Whenever a large number of sunspots are observed on the surface of the sun, there are more explosion-like eruptions taking place on the sun, and more charged particles than normal are being blasted into space. Their entry into the Earth's magnetic field brings about what is called a magnetic storm, during which large numbers of protons and electrons are precipitated into the atmosphere. These cause the bright, varying forms of the Northern Lights. A very powerful Northern Lights discharge has been found to correspond to the explosion of several hydrogen bombs. The colors of the northern lights are studied by a photometer. This has a slowly rotating mirror that scans the sky from north to south. Only the wavelengths to be studied are filtered from the light reflected by the mirror. A plotter connected to the photometer states how strong the colors of the northern lights are in different parts of the sky. The light from the northern lights is not constant, like the light from the sun, in which all the colors appear simultaneously. Only a few specific colors appear in the northern lights. The main color is a greenish yellow. To begin with, the color was thought to derive from the gas krypton, but it has subsequently been proved that the greenish-yellow color arises as the electrons collide with oxygen atoms. Higher up in the atmosphere, there's often a bright red light. This originates from the reactions taking place in the oxygen atoms. Sometimes electrons penetrate below 100 kilometers, where they collide with nitrogen molecules. The result is a faint bluish or violet light, and sometimes a momentary band of deep purple underneath the green northern lights. This color is rare, and its occurrence is an indication of the collision of high-energy particles with the atmosphere. There are also northern lights on the light side of the globe, but they can't be seen in daylight. The frequency with which the northern lights appear can be followed round the clock using a VHF transmitter. If there's no obstacle in the path of the VHF waves, they proceed in a straight line from the transmitting station, finally fading into space. But if there are strong northern lights in the path of the waves, the lights act as reflectors. Some of the waves are then reflected back, and the transmission is received either at the same station or at another suitably located station. One very interesting point about the northern lights is their sound. Many explorers have made notes on the sound phenomena in the course of polar expeditions, and these notes are very reliable because we know that they were made by scientists. Ordinary people claim that these sounds do occur, and they're described as hissing or crackling, just as if straw were being shaken in a sack. I personally don't know what sort of sound there is, but some people claim they have heard sounds. Nowadays we know that no sound audible to the human ear can reach the Earth from the northern lights. If anything is heard, it's a byproduct on the ground. A pressure wave from space can be noted only with special equipment, and the same applies to the electromagnetic oscillations occurring in conjunction with the northern lights. In this room, we register the sound from the northern lights. The room is made of copper, so that all disturbances can be eliminated. This is a Faraday cage, inside which there's no electric field whatsoever. We record on magnetic tape, and also with a pen recorder. We can also listen to the sound obtained through the tape recorder. Here, the recorded tape is speeded up 2,000 times, so we can hear the recorded phenomena as an audible sound. Normally, of course, you can't hear the sound made by the northern lights. The northern lights are also studied using rockets nowadays. From rockets, it's possible to inject, for instance, barium, which is a primary element, and one of the earth alkali metals into the area to be studied. Under the influence of ultraviolet light from the sun, this begins to glow. By photographing the movements of this artificial plasma, it's possible to discover the electric and magnetic properties of space. Since 1957, several satellites have been sent into orbit to study the primary particles giving rise to the northern lights. Some of the satellites have studied the northern lights by photographing them and measuring their colors. The weather satellites, for example, photograph the northern lights while flying across the dark side of the globe. For several years now, the results of this photography has been at the disposal of researchers in Finland. In this photograph, taken by satellite, we can see the entire northern lights oval. The light area in the top right-hand corner is caused by the sun. Finland has no satellite program of her own, but at Utsjoki in northern Finland, there's a research satellite control station for the northern lights area. The satellite EROS measures the electron density of inner space, the shortwave solar radiation, the temperature of electrons and ions, and the densities of neutral particles. All this information is needed to determine the enigma of the northern lights. When the satellite reaches a suitable distance from Utsjoki, the land station gives the command for the tape recorder at the satellite to run, and then the data recorded by the satellite is transferred by radio to the tape recorder at the station. From here, the data is sent to the Oberpfaffenhofen satellite station near Munich to be studied and processed. The appearance of the northern lights is nowadays observed chiefly by fully automatic film cameras of special construction that start up by themselves at dusk and stop at dawn. The northern lights can also be filmed on ordinary cameras. In our film, all the movements of the northern lights have been speeded up, but in reality, equally quick, sometimes even quicker northern phenomena may sometimes be observed. The fully automatic camera at Ivalo, in northern Finland, is in the care of the Pustinen family. Members of the family take it in turns to see to the camera on the roof of their house. The camera is used to film a spherical mirror, in which the whole arc of the sky is visible. Usually 1 photo a minute is taken, but at specially interesting times, more frequent shots can be taken. The camera also records on film the exact filming time, indicated by a crystal clock. By looking at the color film obtained, it's then possible to follow the events leading up to the northern lights, their movements, variations in the colors, and the strength of the light. These are northern lights in the sky over Utsjoki. The sky over the filming point can be seen in the spherical mirror film. The horizon moves round the picture. The north is on the upper edge. For scientists, the films are valuable material for their studies of the complex series of events in inner space, which result in the northern lights and the powerful electric currents and magnetic disturbances in the ionosphere. Professor Heikkila, what is the purpose of Northern Lights research? We can really answer that in two different ways. First of all, it need not be of any benefit to scientists, so long as it's interesting work. Then, secondly, when something has been studied, it's always finally brought to light something of benefit to mankind. Research is interesting in itself. Everyone wants to know and understand how the world functions. And we don't yet know how the northern lights arise and what happens to them. A lot of research has been done over many decades, but still not everything is clear. During the past 10 years, using rockets and satellites to help us, it looks as if rapid strides have been made in research. In a few years' time, certain questions will probably be answered, since a big international magnetospheric study, the IMS, is planned. International magnetospheric study. One nice thing about studying the northern lights is that they arise in the Earth's magnetic field, the magnetosphere. There's plasma there. It's like a big plasma laboratory of its own, where cosmic processes take shape. If we can find out about this, we can use the same knowledge to examine the explosions and discharges taking place in the sun, on other stars, and in space. If we conjecture as to how it may benefit mankind, there's at least one possibility that we might get energy. Energy may be produced by a fusion reaction, the same reaction as is used in the hydrogen bomb, but somehow it must be controlled, so that it can be used without danger. Probably the plasma physics processes acting in the magnetosphere can be used in making a fusion reaction. Tapahtuu justiin siinä, tai voit käyttää siinä fuusioreaktion tekemisessä, laittamisessa.